Hello and welcome to the Chemistry Solution. This tutorial is on balancing combustion reactions. For the purposes of this tutorial, we'll focus on hydrocarbon combustion. And that means we'll combust hydrocarbons, which are compounds that contain only carbon and hydrogen, and we'll assume that these react with O2 in the air to form CO2, which is carbon dioxide, and H2O, which is water. We'll also assume complete combustion, which means that the only products formed will be CO2 and H2O. Let's start by balancing the following equation. The first thing we need to do is to take an inventory of how many of each type of atom we have on the reactant side and the product side. On the reactant side, we have 5 carbon atoms, 10 hydrogen atoms, and 2 oxygen atoms. While on the product side, we have 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. I think that it's always helpful to start balancing combustion reactions by balancing the number of carbon atoms first. And we need to remember that when you balance equations, you can only add coefficients in front of your molecules. You can never change the subscript, because if you change the subscript, you change the identity of the molecule. Now, because we have 5 carbon atoms on the reactant side, we need to put a 5 in front of CO2 on the product side to give us 5 carbon atoms on the product side. But by putting a 5 in front of CO2, we've not only changed the number of carbon atoms on the product side to 5, but we've also changed the number of oxygen atoms on the product side. So we have 10 oxygen atoms from CO2 and 1 oxygen atom from H2O, giving us a total of 11 oxygen atoms. Now let's balance the number of hydrogen atoms. And the reason I'm choosing to balance hydrogen first, before oxygen, is because hydrogen occurs in only 1 compound on the reactant side and 1 compound on the product side. So because we have 10 hydrogen atoms on the reactant side and 2 on the product side, we'll need to put a 5 coefficient in front of H2O to give us 10 hydrogen atoms on the product side. But in putting a 5 in front of H2O, we've not only changed the number of hydrogen atoms on the product side, but we've changed the number of oxygen atoms as well. So we now have 10 oxygen atoms from CO2, which we found by taking 5 times the subscript on oxygen, 2, to give us 10, but we have an additional 5 oxygen atoms from H2O, giving us a total number of oxygen atoms of 15. Now we need to balance the number of oxygen atoms. Now you'll see that we have O2 on the reactant side, and we have 15 oxygen atoms on the product side that we need to balance. Now putting any coefficient in front of O2 is going to give us an even number of oxygen atoms. And so the trick to balancing these combustion reactions is to start by putting a fractional coefficient in front of O2. So in this case, we'll choose 15 halves, because 15 halves times the coefficient on O2, which is 2, gives us 15 oxygen atoms on the reactant side, which now balances with the 15 oxygen atoms on the product side. But we can't have a balanced equation with fractions as coefficients, so we need to multiply all of the coefficients in our entire reaction by 2 so that we have all whole number coefficients. And when we do that, we'll see that we have 2 C5H10 plus 15 O2 gives us 10 CO2 plus 10 H2O. And if you count up the number of carbon, hydrogen, and oxygen atoms on your reactant side, they will equal the number of carbon, hydrogen, and oxygen atoms on your product side. Let's try another problem. In this reaction, we're combusting hexane, which has the formula C6H14, in air. And the molecule in air that's going to react in this combustion reaction is just O2. Now hexane and O2 will combust to give us CO2 and H2O. So first let's take inventory of how many of each different type of atom we have on our reactant side and our product side. And then let's start by balancing the carbon atoms first. So to balance out the 6 carbon atoms on our reactant side, we need to put the coefficient 6 in front of CO2. That now gives us 6 carbon atoms on our product side. but it also increases the number of oxygen atoms on our product side. So we have 12 oxygen atoms from the 6 CO2 molecules plus 1 oxygen atom from H2O. Let's balance the number of hydrogen atoms next. So we have 14 hydrogen atoms on our reactant side, and so in order to have 14 hydrogen atoms on our product side, we need to put the coefficient 7 in front of H2O. That gives us 7 times 2, 14 hydrogen atoms. But it also increases the number of oxygen atoms we have on our product side. So now we have 12 oxygen atoms from our 6 CO2 molecules, plus an additional 7 oxygen atoms from our 7 molecules of H2O, for a total of 19 oxygen atoms. Now, just like in our last example, we have O2 on our reactant side. So any whole number coefficient we put in front of O2 will give us an even number of oxygen atoms. And we have 19 oxygen atoms that we're trying to balance on the product side. So let's start by putting a fraction coefficient in front of O2, 19 halves. 19 halves times 2 will give us 19 oxygen atoms. So now the number of oxygen is balanced. But we can't have a fractional coefficient in our balanced equation, so we need to multiply the entire equation by 2. So that gives us 2C6H14 plus 19O2 gives us 12CO2 plus 14H2O. And when we tabulate the number of carbon, hydrogen, and oxygen atoms, you'll see that we have 12 carbon atoms, 28 hydrogen atoms, and 38 oxygen atoms on both the reactant side and the product side. And along with the fact that all of the coefficients in our balanced equation are in their lowest ratio, means that this equation is correctly balanced. Thanks for watching the chemistry solution. We hope you enjoyed this tutorial.